experiment. This is experiment 3 on the website. It's reacting iron 2 sulfate and potassium permanganate together. So we're just going to add a little bit of iron sulfate in the bottom of a test tube. Iron 2 sulfate is a very, very pale greeny blue colour. And then we're going to add a few drops of acidified potassium permanganate. That's that beautiful purple stuff that we use quite often. It's a well-known oxidant. So let's go to the lab and do that. We'll make some observations and then come back to this. Okay guys, so we've got our iron 2 sulfate here and our potassium permanganate. And I know it can be quite hard to tell because it's quite a low, it's very low concentration, 0.1 moles per litre I think. But this iron 2 sulfate is technically, if you saw a big batch of that, it would have a slight greenish tinge. It's really difficult to see if you have a low concentration. Sometimes you may be able to see it in a light or with a white background, but it's really hard to tell. But for all intents and purposes today, this is going to be a very pale green colour. Put some in a test tube. Alright, so we're going to add some purple potassium permanganate. I do have a sample here. You can see it's a lovely bright colour. We're just going to add a couple of drops into the test tube and see what happens. Give that a bit of a shake. Oh, that purple colour decolorizes straight away. Add a couple more drops so we can see that. So those are observations. Now we started with iron 2 sulfate. So what I'm going to do is I'm just going to whip down and get some potassium thiocyanate. That would turn a blood red colour if we had any Fe3+ ions in there. We started with Fe2. But we've just done a redox reaction now, so we can see if we've made any other iron species in that reaction. So here's some thiocyanate that I've got. If we had any Fe3+ ions in here, this colourless solution would turn into a dark red clear solution. Here we go. Not quite dark red. I guess it's still a result. It might just be because of the concentration of the ions in there. So, but looks kind of orangey, but you would say that you have a positive test to confirm the presence of Fe3+ ions. So we're back from the lab. Let's write down what we saw. So the very, very pale green blue colour starts to disappear or fades. You may, like we didn't really see it, but you may see a slight orange colour coming in. A slight orange colour formed in the solution. The purple permanganate, as we're adding it, we can see that it's purple, decolorizes as it reacts. So the purple permanganate turns into some sort of colorless species as it reacts. Alright, we could have, and we did it in the lab, you can use a confirmation test. We didn't see any solid particles in the solution, so we could do a confirmation test using thiocyanate ions. They will react with iron 3+ ions to form a complex. So a dark red solution was formed, which indicates that that complex was made. So that indicates that we did have Fe3+ ions. So we've just done the observations here. Now we need to write what was happening in terms of oxidation and reduction. So iron 2 in here being a pale green colour, that indicates that we have iron 2. We also know we started with FeSO4, so we know we've started with the iron 2 plus ion. That has done something and now turned into Fe3 plus, because we confirmed that we had that in the test tube after the reaction happened. So that changed to Fe3 plus. We need to make sure we can say what's happening with the electrons here. To go from a 2 plus to 3 plus, to get something that's an ion that's more positive, it must have lost a negative electron. So that electron is now kind of free in the solution there. So this is oxidation, because we got a loss of an electron. We've written it here on the right hand side. The reduction is what the other species has undergone, so that would be the permanganate ions, so MnO4-. Now this starts to get a little bit complicated, so I'm going to leave quite a bit of space here and put the arrow there. This was the purple species, and it changed to something that was colourless. That is actually a manganese 2 plus ion. These are things that you need to be familiar with and you need to memorise, so that when you make your observations you can kind of, I guess, make a inference as to what species you have. So here we need to balance this equation. We've got 4 oxygens on this side. So in order to add them in a redox reaction, we need to add them in the form of water. So we're going to add 4 H2O's there. Now that also introduces hydrogen into this mixture, and this is why we do this in acidic conditions. We've got actually 8 hydrogens here that are not accounted for at the start. So we need to add 8 hydrogens in the form of hydrogen ions. Cool. So that's all the atoms accounted for, but let's look at the charges here. So we have a 1 minus and an 8 plus. So on this side we actually have kind of, I guess, a 7 plus charge sitting on this side of the arrow. Here we only have a 2 plus charge. So in order to get these to be the same, we could take this kind of 7 plus down to a 2 by adding 5 electrons. So now we have 8 positive things, 6 negative things. That gives us a total of a plus 2 charge on this side. And now we have a plus 2 charge in total on that side of the arrow. So that's the reduction. If we have to write them together, we need to make sure all the electrons are accounted for. Here we had 5 electrons. Here we only had 1. So for every time this reaction happens, releasing 5 electrons, or gaining, 5 electrons, this reaction has to happen 5 times. So I like to do big brackets and do a big times whatever, so I remember. And that means that the electrons will cancel, so now all we have to do is just write everything else that we've got. So 5 irons, 1 permanganate, those 8 hydrogens that were there. We're going to have those electrons being cancelled, so now we can do our arrow. We're going to have 5 Fe3 pluses, and then the manganese ion and the water. 4H2O. So that is your balanced equation. To justify what you saw happening here in terms of oxidation, the Fe2 plus species lost 1 electron to become Fe3 plus. This was green. This was confirmed with our SCN, our thiocyanate ion that we added to get that blood red colour. So a loss of electrons indicates that we have oxidation occurring. If you're looking at oxidation numbers, Fe2 plus has an oxidation number of +2 because it's the same as the ion. Here is the same again, it's going to be a +3, same as the ion. So that's an increase in oxidation number. That implies that oxidation has occurred. So the Fe2+ species oxidation number of +2 has increased to a +3 oxidation number in the iron 3 species, again indicating that oxidation has occurred. This is my shorthand, by the way, so you would write this out in full sentences, yes? So you can't assume that we can interpret your shorthand. For permanganate, we have to just look at the manganese species in this form. So what's happened here is that this has gained 5 electrons throughout this reaction to become a manganese 2+ ion. So again, referring just to the species, the M in species has gained 5 electrons to become an Mn2+ species, or where you could use oxidation numbers, and it gets a little bit tricky. You have to remember that an oxygen gives a +2 to all of the oxidation numbers it has, so that's actually got +8 there for the oxygen species. The total has to come to a -1. Oh, sorry, a -2 for oxygen, my bad. So that gives us -8. We need to consider that this whole thing has to come to a -1 charge. So the oxidation numbers need to allow for that to happen. That means that this one manganese species, has to have an oxidation number of +7. On this side, it's easier because you can just see that it's a single ion. It's going to have the same oxidation number as its ion charge. So this manganese species has gone from a +7 to a +2. That's a decrease in oxidation number, and that implies that reduction has occurred. So the Mn species in the permanganate ion has oxidation number of +7. This has decreased to a +2 in the Mn2+ species. A reduction or a decrease in oxidation number implies that reduction has occurred. So I hope that one helps. This one's getting a bit more meaty. We've got a few more things happening here, and there is more room for error. So again, it's just a lot of practice and a lot of experience, but I hope this video helps.